Assalamu alaikum. Good morning, everybody. This presentation I already did to SLB. This is my second time doing a presentation towards my internship course. This is my mud engineering experience as a co-op and SLB. To be specific, in rig science as a mud engineer. First of all, this is my presentation agenda. I'm gonna talk about me, my timeline journey, mud engineering experiences, and general knowledge, specific details, problem challenges I faced, safety suggestions, and finally with the Q&A. About me, I'm a mechanical engineering student at West Mohammed Al. I got diverse expertise. I volunteered in ITRA. I got an intensive English program in USA, exactly at Arizona State University, and also studied at Mesa Community College. My SLB journey. I started with NIST and SIP courses. Then I took the H2S, Housecom, First Aid, Firefighter course. I was located in Rig ADC 42, then relocated at Rig ADC 66. Then I spent a couple of days at a well construction fluid laboratory. What's mud engineering? Mud engineering is providing the suitable mud properties for well and formation demand and need. I think ourselves like doctors, we are the doctors, our patient is the well. We provide it with medicine as per required. Mud engineers' duties and responsibilities. We got to check the mud properties, chemical inventory, tank volume planning, creative solutions, safety and compliance, reporting and handover, field observation, coordination for the crew, and finally with professional communication. Now we're going to talk about the section and well designs. As you can see here, we got four main sections. We got four main well designs: K2, MK2, K1, and MK1. There are three different sections: top, intermediate, and production. There are three main shapes for any section, for any design. Either the S shape, or the horizontal, or the vertical, depending on study before rigging the design. We know what shape we use. Formations. Every formation has its own problems, properties, and special mud treatment, caution, and special operation. As you can see here, these are the formation that we deal with. For example, Sheba is a sand formation. Collapse may occur. Also, Khuf is a high pressure formation. It has its own special operation and cautions and properties. So we need to know each formation and what to do with it. Overview. I worked in Athmania 3149 and Alhamdulillah, I'm happy to say that we did the high score with 53 days. It's considered like the fastest LSTK well that ever been done in Athmania with 53 days. Aramco planned for us 80 days, but we finished at 53. As you can see here, this is our game plan, our formation, and our design. Our design was MK1, starting with 34 and finishing at 578. Understanding the game plan. Each mud type has its own properties, characteristics. Why we use spud? Spud mud is low cost and give us stability. Also, BHPA gives us shell encapsulation. Ibentonite And VHPA mud, cybentonite is the same idea of spud but with high concentration of bentonite. We use it in shape as we said before because it has sand formation. It may collapse may occur and we need to stabilize. Also, high bentonite gives us high gels. High gels are important for us mud engineers to maintain the viscosity of our mud. On the other hand, the KCl polymer mud gives us shell inhibition and prevents swelling. Finally, with the OBM, or also called Reheliant mud. Reheliant mud, it's for high temperature and high pressure. Down there, it's high temperature, high pressure. We use OBM to sustain the mud properties and to make sure we have no losses or any problem. Now, how mud weights are assigned? This is a good question. I always ask myself. We got hydrostatic, formation, and friction pressure. Hydrostatic needs to be higher than the formation, but not higher than the friction. If hydrostatic exceeds the friction pressure, losses will occur, and it's a big problem. On the other side, if formation is higher than the hydrostatic, kick and flow out will occur. So we need to balance the pressure. Of course, as you know, hydrostatic pressure is the mud weight pressure through the true vertical depth, and the formation pressure is the formation kicking back pressure. Our second factor is cost and time. Each chemical has its own value. Some is expensive more than the other, and some take time mixing than the other. As you can see here, OBM, its main mud, mud weight material is barite. Barite takes a lot of time to mix. Basically, mud weight is density mass per unit volume. Understanding potential problems and their solutions. Each problem you see here in our game plan defines the formation problem. It's always the formation problem. Then comes our mud problem. Every mud has its own disadvantages and we deal with it. So, us as mud engineers, long vision is required to prevent any problem. Understanding potential problems, these are the main solutions for the main problems. As you can see here, we have the loose circulation material. We use it in loose situation such as total loss, partial loss, or seepage loss. We use the loose circulation material right before and during the loose situation. Mud cap. Mud cap is, if I call, a technique used while having loose situation. It's always 10 PCF higher. 10 PCF means 10 more mud weight higher than the usual mud we are using. Bridging material. Bridging material is for sustaining the formation for expected losses. So we use it before having a loss to sustain and stabilize the formation from breaking in and sealing the formation. High T, high P chemicals are also called high temperature, high pressure chemicals. We use it to sustain the mud properties from high temperature and high pressure. Also minimize the fluid loss. Lubricant, we use it in tight spots, also helps us with drag. Thinners is used to reduce the viscosity when needed. Also, in a situation called pitbull, we use it to fix the pitbull problem. Also mixed with nut plugs to fix the pitbull problem. Managing mud tanks. It's our responsibility, as I said, mud engineers, to manage mud tanks to make sure everything goes according to the plan. Starting from the right, as you can see, active 1 tank, active 2, ending to the water tank from the left. These are the main mud tanks we use. We mix in, we send it to the well, we pump it, we play with these tanks. For example, we got a problem in S1, or also called Slug 1. We have a slug pipe, a special mud type. It was contaminated and leaked from water tank to Slug 1, so our mud was contaminated. So we need to send it back. We need to make sure that it's not contaminated. So we figured that there was leaking and to send it back to the C4, also called cement tanks, and mix the new slug. Other example is for active one. It was OBM there, and we needed to dump the OBM, but we cannot dump it. Cleaning crew is here. We cannot clean it. We cannot send it anywhere. So what we did is to send it to flag tank, and so they can clean the OBM and proceed to the next procedure and drilling or using another fluid. After OBM we use a special fluid called brine. It's basically salt and water. Mud systems. Mud systems are the mud route, end route of circulation, starting from the flow line towards active tanks. Mud system serves us mud engineers by cutting and by separating cuttings and gases from mud. We get two systems, long and short, depending on the situation. Us mud engineers decide what to use best. As you can see here, long system, short system. Long system is used when having a lot of cuttings and a lot of gases. We use them to separate and minimize the cuttings there. If not, we use the short system. Also, we have the solid equipment, centrifuge, shale shaker, mud cleaner, desander, and descenders. Also used to separate mud and gases. Circulations and reverse circulations. Circulation starting from active tank to the section line, mud pump, stand pipe, sending it to the top drive, sending it back down to the drill string, back to the annulus, flow line, and then come to our mud system I just explained before, and return back to the active. Reverse circulation, same idea, but when we're having water or acid and we don't want it to contaminate the annulus, we pump it through the drill string. Before reaching the annulus, we pump it back through also the drill string, sending it back to the flow line. Displacement. Displacement is the action of removing a fluid with other fluid from the wellbore using a pump. We can know displacement coordination by two ways. Either by calculating number of strokes and volume pumped, it gives us what number of strokes your displacement fluid will be out. Or by manually observing or testing the fluid from the flow line. You just go to the flow line, clicking your equipment test, such as mud weight, balance, or the electric stability meter. You can figure out, or also by color or by smell, depending on the fluid you have. You can know what's there and what's still in the well. Mud uses and their type. We got two basic mud weight, water base and oil base. Also a special fluid called brine. What's the mud uses? Stabilizing the well, pressure equilibrium, cooling drill bit, and removing cuttings. Test. We got three different tests. Okay, anyhow, safety and environment. Safety and environment, we got work permits, safety meetings, stop work authority, RIR. This is all the tools that helps us to to minimize any danger and protect ourselves. Safety meetings, I usually took them 2 times a day, one in the midnight and one in the morning. We They give us a brief, what's our operation today, what to be careful of, and what's the precautions that we need to take care of. And for the environment, we don't dump the OPM, also the diesel, also the brine, also the acid. We don't dump them for the environment. bromide drums backloading. Aramco bromide drums, we cannot backload it until it's fully empty, so they can recycle it the correct way. Also filtrating water from the well, the water that we use inside the well, when we send it, we take it back, we do not dump it, we send it to the filtration unit, and filtration is well filtrated and sent back to our water tank. These are some important mud engineering formulas. As you can see here, we can know the oil ratio, water ratio, and oil water ratio. Excess lime for the alkalinity test. How to reduce the mud weight using diesel. And in the top right, the total circulating cycles and strokes. This is the one I talked about displacement. You use this formula to know which stroke you will receive your mud. Also the kill mud weight shutdown pipe. If you want to shut down your mud for any reason, want to kill the line, kill the wellbore, you use this formula to understand and to get the specific pressure you need to finish the wellbore. Also, you can know the brine density by this formula. Also, there is a test you can do it. It's called hydrometer if you don't want to use the formula. Finally, about increasing the mud weight by barite. So these are the most common formulas that we use as mud engineers. Operation problem I faced in field. As I said before, our slack pipe was contaminated. Centrifuge from the mud system wasn't working and we need to cut the mud weight down. So we opened the long system so we can fulfill the shortage. Fluid loss. We had fluid loss in our mud, so we added the HTHP chemicals. Rheology was high, so we diluted it by diesel. Our wash pipe in the rig floor exploded, so we lost around 50 barrels of mud. Operation was stopped for a couple of days. This hurt us as a mud engineer. Finally, mud weight was high and rheology was needed, so we cannot dilute because dilution decreases the mud properties. So what we did, we opened the long system, centrifuge, every equipment, solid equipment we have to decrease the mud weight without diluting. Finally, mud pump was inefficient. Our mud pump assigned to us mud engineers wasn't efficient, so we used the cement tank, cement unit pump, so we can fulfill the shortage of our mud until it's fixed. These are some honorable mentions. We got the slack pipe, a special type of mud. We do it to sustain the pressure inside the rig floor. Log and fill, it's also a special mud type used by, we created for the team of login so they can use it and take their logging from down the wellbore without any problem. It's idea that we have high rheology in our mud so we can suspend the cuttings so their equipment can go down easily. Well water check, we need to check the water before entering any rig or any operation to make sure our mud can work with this. Like for example, chloride and calcium needs to be lower than, chloride needs to be lower than 400 and calcium needs to be lower than 600. If not, it's a problem. We cannot use the water for our mud. We need to contact Aramco to provide us with new water. On the other hand, open item or also called action item, some inspection, when some inspection happen in our rig and there is a problem, they give us a note called open item. Please, you mud engineers, fix this problem. Also, we have the YouTube. YouTube is when having multiple mud weights in the same wellbore, inside the wellbore. It can cause you a lot of trouble. Multiple mud weights with the same fluid can push each other and make it unstable down there. Finally, with the trip tank is on our rig or in our system. Basically, it's used when tripping out. Uh, when tripping out, the volume will be down due to metal displacement. So the Wilbur needs also always to be full. So we give them some volume inside the trip tank so they can use it. The floorman and also the driller tool pusher, they can use it whenever they are tripping out the metal displacement to make sure that the Wilbur hole is fully empty and even one barrel left. Finally, with the bacteria can live in water environment, so it's a problem for us. Two major reasons: smell and also it kills our mud properties. Bacteria feeds on our mud properties and make them less by time, so we treat it by giving or spending a SIMPF chemical every 12 hours to make sure bacteria are killed. Challenges I faced: adapting the work environment. As you know, I worked in a rig. This is my first time. I spent there like around 40 days. It was hard. There was no Wi-Fi. Also, sharing a room with random people every couple of days. They sent me to another room, and I spent with a new guy, sleeping with a new guy. Finally, my first week was so hard. There was a lot to consume, a lot of information. So, and this brings me up to the suggestions that I make. I made this paper. It will be sent with the email. It's a quick brochure I did to help the future co-op in SLB. It contains the main points such as safety, key terms, rheology and mud types, common chemicals. If I had this paper in my first week, life would be easier. So I did it and suggested to SLB, and they approved it and they took it gladly. And yes, thank you very much for listening. This was my presentation.